Hello, this is Chapter 16, Risk Analysis and Simulation. Here are our learning objectives for today. Perform risk analysis, generate random observations from probability distributions, develop and apply Monte Carlo simulations, Fashion Tech's best-selling item is a red pullover jacket for women. Abigail, the company's operations manager, is looking for a better, more data-driven strategy for production and staffing for this product. Although the production process for the pullover is partly automated, many important steps are done manually by skilled tailors. Abigail wants to get a better estimate of the demand of the pullover and determine how many tailors she needs to hire. In addition, she is considering increasing the level of automation in the manufacturing process. Abigail would like to accomplish the following tasks. 1. Develop a simulation to examine the profit at each staffing level, as well as evaluate the plan to increase the automation level in the production process. 2. Examine the profit variability given the uncertainty of the demand and the production rate. Prescriptive analytics is a process of using analysis tools to improve decision making. In many cases, prescriptive analytics can help a decision maker determine the best course of action among different alternatives. Some people regard prescriptive analytics as a very broad term that encompasses all analytics techniques with an overall goal of improving business decision making. Most people prefer making a distinction between descriptive, predictive, and prescriptive analytics. Prescriptive analytics uses simulation and optimization techniques to quantify the effect of different possible actions by a decision maker. There are 3 analytics techniques used to extract value from data and make better business decisions. Descriptive statistics summarizes what has happened: gathering, organizing, tabulating, visualization. Predictive analytics predicts what could happen using historical data for predictive models. Prescriptive analytics provides advice on what should we do. It's the process of using decision analysis tools to improve decision making. Simulation is an attempt to imitate a real-world process, examine the outcome of different scenarios. Optimization is an attempt to find an optimal way to achieve an objective under given constraints. Assessing risk. Simulation has been extensively used in a wide variety of applications to explore alternative solutions or improve decision making. Risk can be defined as the possibility or probability that an undesirable outcome may occur. Risk analysis, also called scenario analysis, refers to a process of examining and assessing different scenarios in order to better understand the possibility of both intended and undesired outcomes. We can assess and model risk using random variables and risk analysis. Use random variables to capture the inherently uncertain nature of processes to make better informed decisions. Examine multiple scenarios with different possible outcomes to assess risk. Consider at least 3 scenarios to evaluate a range of outcomes from multiple scenarios. 1. Most likely. 2. Worst case, pessimistic. And 3. Optimistic or best case. Also consider the average scenario or others. It may be difficult to determine what the best or worst cases are. Use historical data to help estimate the best and worst cases. Considering at least these 3 scenarios reasonably captures some of the uncertainty of a real-life process. Example: a company in the western United States manufactures and distributes women's handbags to retail stores around the country. To manufacture a handbag, the company usually incurs a variable cost of $40 per handbag, but the actual costs in the past have ranged from $35 to $46 per handbag. The overall fixed cost is usually $43,000, but may vary between $31,000 and $52,000. The retail price of each handbag is $65. Based on a small amount of sales data available, the demand has fluctuated between 2,500 and 5,000 handbags per quarter, but in most quarters the demand has been about 3,500 handbags. Conduct a risk analysis to assess the quarterly profitability of the company. So this is an example here with Excel. Profit equals the retail price per handbag minus the variable cost per handbag times demand minus fixed cost. And if we open up a handbag worksheet, we can plug in all of the different variables. And this is continued with R. We also use random variables to assess risk and uncertainty. A random variable is a function that assigns numerical values to the outcome of an experiment. Important discrete random variables include discrete uniform, binomial, and Poisson. Important continuous random variables include continuous uniform, normal, exponential, and triangular. Example, a company estimates that 30% of its customers would react positively to its new web features. Here, we demonstrate how to generate random observations that represent the number of customers who react positively to the company's new web features in a randomly selected group of 10 customers. Simulate random observations based on 100 groups of 10 customers. So this is an example, continue with Excel, and we'll do it this way. This is with R. In many real-world settings, the appropriate probability distribution of a random variable is not known in advance. Plot the data and inspect the histogram for distinctive shapes corresponding to theoretical distributions. But many real-life events and the data we obtain from these events may not conform to any theoretical probability distributions. Construct and use an empirical probability distribution by using historical or empirical data. An empirical probability distribution can be represented by a relative frequency table. Cumulative relative frequencies are then used to generate random observations that reflect the pattern observed in the historical data. Example, a medical supply provider examines the weekly demand by hospitals for respiratory ventilators. Ventilator demand, the frequency. Construct 100 weekly demands for ventilators based on the empirical probability distribution. And this is continued in Excel. And the data analysis on random number generation. Here it is with R. A triangular distribution is a simplistic representation of a continuous probability distribution with a triangular shape. It is defined by 3 parameters: the minimum value, the maximum value, and the mode. Sometimes the minimum value represents the worst case scenario, and the maximum value represents the best case scenario. To represent the most likely scenario, we usually use the mode. Sometimes we also consider the average value to represent the most likely scenario. When symmetrical, the mode and the mean are the same. Using random numbers in order to model uncertainty based on a triangular probability distribution, let x be a random number uniformly distributed between 0 and 1. And this is the formula that we would use. Example, the handbag manufacturer determines that its worst, best, and most likely profit or loss are minus 4,500, 119,000, and 44,500 respectively. Because we have no detailed historical data or additional information to make assumptions about any theoretical distribution, we use a triangular probability distribution to assess the uncertainty of the manufacturer's profit. Generate 100 random observations based on a triangular probability distribution. Here it is with Excel, and then here it is with R. Monte Carlo simulation. Computer simulation is often synonymous with the Monte Carlo method, named after the Monte Carlo Casino in Monaco. Monte Carlo simulation is used to understand the impact of the risk and uncertainty in a wide variety of real-world process or system. The technique relies on random variables to mimic the odds of all possible outcomes. Monte Carlo simulation is also called probabilistic or stochastic simulation. There are 5 steps to Monte Carlo simulation. Number 1, data collection. Gather historical data to make an assumption about the probability distribution. Estimate the empirical probability distribution. Number 2, random number generation and assignment. 3, model formulation. Construct a quantitative model to represent the relationship. Capture the uncertainty of the random variables as related to the outcome. Number 4, performing and repeating the analysis. And 5, interpretation of results. Example, Abigail wants to develop an analytical model to analyze the demand and production information for a red pullover jacket for women, the top selling product for fashion tech. She obtains relevant demand and cost information from her corporate database. We've got description, where we have weekly demand, weekly production rate, selling price, et cetera, and then we have the data. The task, develop a Monte Carlo simulation to help Abigail examine the profit at each staffing level. Example continued, construct a quantitative model that represents the relationship among the relevant variables. So profit equals revenue minus cost equal RQs minus F plus VQ sub P, where R is the selling price of the jacket, Q is the number of jackets sold, F is the fixed overhead cost, V is the variable cost per jacket, and Q sub P is the number of jackets produced. Here we have plugged in the variables in Excel, and then we have it continued with Excel, and then we can see it plotted, and then we can see all of the information here. Then we have it with R. Continue with R. And the last one. Thanks for listening.